I'm recording this, and as I said, some parts of this I will much later put on YouTube.
Yeah, sure.
There are some small issues about the statement, but this is not really important right now. Like here you say the number of players and the number of players in the list. Like it's bad. This repetition is bad, so it's better to do the number of players and the size of the list, or the number of names in the list, something like that. Otherwise, it's hard to understand. And as I already said before, the review button is very important, and this way check each condition if it matches, the validator matches the statement. The review button is the most important thing in Polygon. Everything else is kind of automatically checked by Polygon. So here n should be from 2 to 1000, but in Validator it is from 2 to 100. Also, this limit is bad. From 1 to n versus from 1 to 100. In particular, this validator will accept a test of n equal to 2, k equal to 1, and then 100, some invalid number. Later, maybe we can talk also about validator tests. It's very important to here put several invalid tests. Like you see you see limits in the statement, like n is from this to that. Then put two tests for that in validator tests. One where it's too small, one when it's too big. And same for kind of try to hit with different tests every condition. This valid test doesn't matter much. You need to create a lot of invalid tests here and make sure that your validator says they are invalid.
Yeah, I get that, but validator is used mostly for hacking, right?
Oh, no, the validator is here to check if your tests are right.
Yeah, but if I make the generator, I know that the tests are right.
Did you never make a mistake in your life?
I mean,
the thing is, of course, in a very easy problem, it's very likely that your generator is fine. And maybe it's 99%. Or maybe it's even bigger. But even if it's 99% that such a simple generator is right, then in the whole contest, you already have like 6% to make invalid tests. Something with like n out of bounds or anything like that. Also, when there is any tester, don't make tester to read your whole generator. Like your generator already here has some like two different types of tests. And how do you know that you didn't put an extra space somewhere or an extra number at the end? Because maybe somewhere you print k values or you print n values instead of k values. And this is the easiest possible problem. Imagine what happens in hard problems when generator will be 100 lines, 150 lines. There, I would say you have 50% probability to make some mistake. So no, validator is very important, and it is to check if tests are correct. Because the contest isn't a disaster if you make weak tests, but it is a disaster if you make invalid tests.
I understand.
And that includes white spaces. Like some people will implement in a different language, maybe in, I don't know, Python, they will read the whole line and split with space, and then maybe some extra space at the end of a line will kill them. And that's bad, because you in the statement you say what is the input format. Validator isn't just for hacks. But the most important thing today is generator. Like, most of this meeting will be about that. Do you guys have any questions about validator for now?
Oh, not really.
Yeah. So this generator is bad for several reasons. I already copied it here, Ginny, so we can work here. Okay, I think with X you generate some type of test between 1 and 3. I don't know if that was intended that with probability 1/3 you will do something else.
Yeah. So I wanted if x equals 2, then the generator will generate a true test. So the answer will be yes.
Okay, I thought that like, normally I would put here, for example, 1, or I don't know. If you want to say probability 1/3, that it's better to do this. If random number smaller than 3 is equal 0. That's a standard way to say with probability 1/3. Because like, this makes sense if you want to do something for x equal to 1, 2, 3, I would say. So this then means with probability 1/3. But okay, another thing is that in TestLib there are a lot of very useful commands that will help you, for example, print with proper number of spaces. And I believe you can do this. Print new line, tk. This should work if my memory is good here. Yeah, you can do that. The same with vector. If you gather something as a vector, then you can do this of vector v, and TestLib has a function for that. It will do it with proper number of spaces. So the first improvement I would do here is to avoid some copy pasting here. Create a sequence A of size k, I guess, or maybe this, with probability 1/3. K is this, a dot resize of size k if you need that. For every I, a of I is I plus 1. Else do that other thing, and only print once. This is already twice, like 2 times smaller code. For every I do this, and here print both things. But this is just, ugliness or not ugliness. In a moment we'll go to real stuff. But also this is much better if you're going to have a lot of types of tests. Okay, now here is the main logic, and then you print independently. Questions for this?
No, not really.
Yeah. The problem was what the statement said. Maybe without the statement. First issue. I can run this now, generator with, did I mess up? Yeah, I did. A resize k. I can run this generator with various random seeds, and I can see what happens. It's quite important with my own eyes to check what happens, and indeed, after I run a few times, I see that sometimes you print values from 1 to n-1.
Yeah, so it's a pattern.
Yeah.
Every time it's yes, then it prints all in increasing order.
So just imagine what would happen here instead if you had huge n, then especially some more complicated pattern would be more difficult to see. Let's say that you decide to make this a little bit better, and after that you say shuffle, or like random shuffle of this. There is a shuffle function in TestLib. If you do this, did I mess up?
You didn't do it the correct if. It should be in the higher
Oh yeah,
if.
you're right. Or I could do it maybe independently of 2 cases.
Yeah.
This. Yeah, so now I see that it's indeed 1, 2, 3, 4, 5. But if n in your problem was up to 1,000,000 or 100,000, I wouldn't be able to see it. So it's much better to take t from the input. Say that the first argument from the input is t, like that, and then this first argument isn't a seed anymore, it is n, and then here you can put seed if you want. For 10, for 100. This way, my generator writing process is that I create such a generator, and n I pass as an argument. And I here cast the first, the arg of 1 corresponds to this value, arg of 2 would be this value, and so on. And then I run with small n to see with my eyes if everything is alright. And then here in tests, you will be able to decide what values of n you want. Maybe you want random values and you want your program to do it, then put here random next between 2 and this. You can do something like that. Or if you really want a lot, to have a lot of decision, say that in the input there is interval. That's the most powerful way to do this. Because then if you put 50-50 here, and then optional seed, this seed doesn't have to be there. For sure, n will be 50. If you want to generate a lot of tests between 2 and 100, do this, second seed, third, and every time n is generated in this interval. By default, use this. Also, in order to run it on your computer and see if everything is alright. And thanks to that, also here you could, I already told you in issue that there is this brief manual and examples. Use that to see how to create variables and for loops here. So all of this, it can be replaced with a for loop. And here, I think I put it in an issue, so I will copy paste. This. For every this as do exactly that. Okay, that's the first fix. I messed up. Maybe should be new lines, I'm not sure. Worked earlier before I copy pasted this to issue. And you can modify this some more if you have proper generator. Like you can say maybe repeat 10 times, and now do this 2, 10 and 200. By doing this, this will already be much better than your tests. Maybe even I want to put more, like 50 small tests and just 20 big tests. That's fine. You want to have a lot of small tests in your test set because it is more likely that they will catch something tricky. If you create a random test with 100 values, nothing is possible there by mistake, by coincidence. In particular, it's almost impossible that all values will occur or something like that. In your current test, it's almost impossible to get permutation of numbers in the input, like this. And I think you already saw that before I got to the problem, there was just one solution. So you usually want 2 correct solutions to make sure that everything is alright, because you can make a mistake. In particular, a mistake can come from misunderstanding the statement. Or like maybe the statement doesn't say what your solution does. Somebody always should, after the statement is written, somebody should look at it and implement their own solutions. So 2 correct solutions are needed. And it's very good to make some incorrect solutions. And in particular, I tried solutions like, what is the mistake here? I said yes if size of possible imposters is 0 or 1 instead of just 1. This is a very important test. Even in the statement you said, if nobody can be an imposter, then print yes. And it isn't covered by tests. This solution incorrectly says yes, and it gets accepted. Then in my second program, instead of 1 through n, I iterated 0 through n minus 1. I said that those are possible names, and it still got accepted. And this got accepted because you generate tests very strangely. You generate them from 1 to n minus 1. So 0 and n, they don't occur. Also, I tried even this more stupid program where I just compare k with n minus 1, but you got lucky, and there are like 4 tests where this solution fails. Just notice that the bigger n is, the less likely anything is to happen. I guess that if n was just always 1000, then this program would fail all your 100 tests. Okay, questions?
No, everything is clear.
And now for this. You'd here just print 1, 2, 3, and so on up to n-1. That's the first issue. That's very basic. If somebody has array too small by 1, or indeed considers things indexing from 0 and instead of indexing from 1, it all works. Instead here I would do, what I would do? I would remove a random guy. Erased is random value from 1 to n for everything from 1 to n. If I is not erased, then pushback. Something like that. But also I would allow here nothing to be erased. If you slightly modify this, you will cover two types of tests. If I allow erase to be 0, then also this will generate tests with everything being in the input. I can, if I want, I can increase probability of this, because right now for like n equal to 100, almost for sure this will generate, erased will not be 0. And I want this to be special case. So instead, I will do erased is 0 if rand.next of, let's say, 100 is smaller than 90, then erased is random next of 1n. Here I said with probability 90%. Like this line, always you can use to say with some probability. This is with probability 1%, with probability 5%. And I will say with probability, I don't know, 60%, erase one of values, otherwise this. Also, k is really redundant and you only can make a mistake with that. I would say it's better not to create a variable k and instead just here say that a.size is k. I mean, sure, you can here choose it, or you can here say, oh, I made it the other way around. This was supposed to be here, sorry about that. But I would say create t, and I will even change this to n because n was in the input, I think. N was in the statement, so let's be consistent. No, what's going on here? Oh yeah, I don't want this because, never mind, because the generator isn't updated in the website. Yeah, n. So this will be my generator. N is random value in given interval. Now, with probability, say 50%, for everything, int k is something. And now, this was very bad, because this means that k cannot be bigger than n. You will not get repetitions. Like, if you get repetitions, it means that nothing is full. No, just make here k. So this was a huge mistake. You can say that k is up to maybe 100. I would say that minimum of 100 and twice n. I would say that this is reasonable. By this I want to say I allow some repetitions, and with this I don't want to exceed limit from the problem. Do you want 100 or 1000?
1000.
1000. Then let's do this. And it will create much better tests, especially if you sometimes allow small n. Int k is this, repeat k times. Did I create a? A is here. Repeat k times, a pushback, random value between 1 and n. Else, do the second thing. No, the second thing was this. And if I compile that, I just need to see if it compiles. Generator 1. Oh, I need an interval. So let's use interval from 10 to 12. It gave me something. The seed doesn't even have to be a number. I can do here various stuff. And if you, for the sake of testing locally, and seeing with your eyes what happens, you can print stuff. So here we'll say erased is this value, and otherwise random. Then it will be easier for me to see what happens. Here I have some random test with 11, n equal to 11, and I here see that all values are up to 11, but I wanted them to be slightly bigger. So let's investigate, let's check. Maybe it happened that here this random value between, maybe this random value turned out to be twice n. Do you see, guys, what's the mistake?
Wait, so you want the values to be bigger? And they
Oh, that's
they have to
forbidden.
be smaller.
That's
Yeah,
forbidden.
yeah.
Never mind, never mind. I thought for a moment that this is limit for values, for every value. No, then everything is alright. There are 20 values, so it's something from like up to twice n. And this this has values from 1 to n. Everything is fine. Okay, let's try some more tests. I erased 0, so this should contain all values from 1 to n. I see that this test is a bit too simple because I just have values in this order. So I'm going to here shuffle. And let's run again. 1, 2, 3. Actually, that's a bit too hard to analyze, so I will use some smaller values. 7, 7 random. Yeah, that looks random. Random, random, erase 2, and there's indeed 1, 3, 4, 5, 6. Okay, so don't ever assume that your generator does exactly what you think, unless you think that you never make mistakes. The point of running this locally is to see what happens, and this way you can keep improving tests. Like in particular, I had this idea with erased 0. So sometimes we will create tests where everything occurs. Also, maybe I want to create tests where 2 things are missing. So I will say erased. This will be set for erased, like forbidden values. How many of them is random value between 0 and 2? It can be 0, 1, or 2. Repeat that many times. At erased, insert random value between 1 and n. Something like that. Then if erased doesn't contain I. Now it can happen that I will erase 2 values. And it is here to check something, to check some programs. The point of test is to catch various mistakes, and you might not think about mistakes that participants will do. Also here, I don't really want a lot of tests with 2 missing values. So I will say int times is 0 with probability, let's say 50%. Of course, you can write it this much easier, but with probability 50% times is 1, and let's say else if this times is 2. Now the distribution I have is with 50% times is 1, with 25% otherwise with 25% this, so otherwise with 75% times is 0. This is a very strange distribution. Maybe this will be easier to analyze. Probabilities random value will do 100. If probability is smaller than, let's say, 15 times is 2. Else if smaller than 65, then times is 1. Else times is 0. I guess that this is the best way to choose something with not even distribution. And the point is to make a lot of tests that are the most important types of tests, and also some variations of that. Here with probability 50%, I forbid one value. With because this is if probability percentage is between 15 and 65, then this will happen. With 15% times is 2, I will forbid 2 values. Otherwise, I forbid I think 0 values. Or you could say that here. You could also do this. Or the number of times erased is this. You can grab it from the input and then decide about it in command line. Like that, this will erase 2 values out of values from 1 to n, but you can just create tens of tests and assume that every type will occur. Yep, we'll compile. You could now locally test this a little bit. So for a moment, I will just remove this. I temporarily remove this to test this part of code. Gen 77. Okay. Let's see, I got values except for 1 and 2. Everything from 1 to 7 except 1 and 2. B. 1, 2, 3, 4, 5, 6, 7. I got all the values. Well, case n-1, so one value is missing. And if I do all of that, I will see that yeah, stuff works roughly as I expected. K is usually n-1 or n, sometimes n-2. If you want to make your code maybe a little bit better, you can do maybe this. A pushback or a pushback round between 1 and n. Or let's say from time to time you do this. This says with probability 50%, add a random value. So that this type of test would also have some repetitions. But only sometimes. It's always better to say sometimes I have this variation. Imagine that you're basically experiment with different possible tests, and tests are strongest when the variety of tests is big. So you always want to create a lot of types. And this way I created this 50-line generator. Actually, well, this can be removed, I guess. So it's fewer than 50 lines. And believe me, it will cover 99% of mistakes in this problem. And let's put it to use. In files, I will upload it. And I will show you what I would do in script. This. It doesn't hurt to leave a few of your tests. So do I have 1000? Because I used some limit there. Where is my minimum? Oh, I remember now. I removed the other type. That wasn't a smart choice. Like this. I should have commented that. Like that, and I said here if this with probability 50%, a pushback random value. Also, why I here have this 2, 1, and 0? Because the special case, you want to check if size of something is n-1 in this problem. So for sure, you want to create tests where this is true and this is true, to make sure that you catch any off by one mistakes by participants. Only in this case you print yes. In this and that you print no. So those are 3 most important type of tests, and I cover all of them here. Okay, yeah, let's. I have a generator, tests. I will leave a few of yours. It doesn't hurt to have multiple types of tests. And then my is. I will make sure that in files there is proper file edit. Yeah, this is the wrong one. Save. And now for starters, I would say generate a lot of tests of what, from 2 to, let's say, 10. Then it's big probability that something special will happen. I would even say from 2 to 5. I want some tests with n equal to 2 and generate for every n up from some value. Actually, I will do for every n from 2 to 10 as n. Nope. Tabulator doesn't work. This and that. Okay, that's some start. If you want a lot of tests, you could actually hit every n from 2 to 100. Let's say that I also want from 2 to 10, like that. We can have a for loop to make more of those, and then some of this also make a for loop, and then 2 max tests, let's say, this and that. And this repeat many times with a for loop, like that. And now this is a seed. Works all right. Any questions about this script?
I don't think I have any questions because I didn't use it before. So, but I understand how it works.
Okay. Read the brief manual and examples to understand the for loops, because sometimes you want to create like 50 tests and you want to repeat a lot of times the same style. Like generally, it's never smart to, I will renumerate automatically. I think I made a bug here. Okay, I cannot renumerate. Was there any reason to include those here?
Yeah, because the last generator I made, when it was true, all the numbers were sorted, so I wanted to include some
Okay.
non-sorted.
It's much. If you created this anyway, you had, I guess, some generator to shuffle those values.
Yeah.
Then it's better to create that generator.
Yeah, I know, but it wasn't with testlib, so I just created this in mine.
I get it. What else? What I also told you in issues is that there should be a sample test. There should be a sample test showing you what happens if all the values are present. So let's create it. 3, 5, 2, 1, 1, 3, 3. Use in statements. Also, then we need to push it to be one of the first tests. I mean, that's otherwise Polygon will say, oh, this is not how it should be. Like that. So now third test. Because we use that, this enumeration is, it says it's bad. I don't know how to fix that well. Edit here. Okay. Apparently I need to click every test. I guess Polygon doesn't like mixing for loops with already existing tests added by hand. Where is my test? Here. Maybe I will also change this to happen multiple times, because as I said, small n will catch a lot of mistakes. You cannot just rely on small n, on test with small n, not to let any brute force pass, but this should be good. If I made any mistake in this script and I create a lot of equal tests, Polygon will also warn you about that. And you can look at your eyes, with your eyes here, like what every test is. For example, I see that here I have a lot of tests with n being between 2 and 10. Then a lot of tests with between 2 and 100, then there are 2 with 99 and 100. You can create more of those if you want. Actually, yeah, I will create more just because in this problem we have just yes, no answer. This, and that. So we need a lot of tests. If it was a Codeforces round, you would need to put multiple test cases here, because yes, no is like easy to hack for participants. I mean, they can easily pass your test by making some extra ifs. If the output is value, then it's harder to get it right. So fewer tests are enough. I think I'm done here. Let's run my solutions. Previously, I think only one of my 4 solutions, wrong solutions, got failed on some test. And now we should see every program fail. And this, there is an issue. There is some format error. Validator says that k equals 124 violates the range of 1 and 100.
I forgot to change the validator.
Yeah, so
I mean, we didn't change it after you told us.
we need to modify this because you said you want, I think, 1,000, right?
Yeah,
Yeah.
1,000.
1,000, and here I believe it should be n, but we will check that later. I still believe that our generator right now can create an invalid test, but we will check that later. Yeah, solution files, invocations, run this again, rejudge, okay. View, and now maybe everything will be all right. Basically, if something is wrong, everything becomes red, and you need to click FL error. So far, so good. Yeah, and all my wrong solutions failed. And this means that tests are quite good. Now, thanks to the fact that I created a generator that takes some arguments from the input, I can stress test stuff. So I can say that now create a lot of tests between 2 and with value n between 2 and 10, and compare those 2 programs against each other for 1 minute. Save and run. Polygon will now, for thousands of times, with different seed every time, it will compare those 2 programs if they agree on all possible tests. This is much better than just running those tests. You want to make sure that your intended solution is right, because maybe later it will turn out that you had some logic error and there exists a test where you are wrong. That's bad. And I think that this is possible, especially for small n. And the reason why I'm saying that is that here we put erased, right? What happens if we erase 2 elements and n is equal to 2? Then erased will be both 1 and 2 possibly, and A possibly will be empty. So I believe that our generator with like 1% probability will put k equal to 0. And it's more likely, I think, for 2, 2. So if I repeat this a lot of times, I think I will get k equal to 0 eventually. I also expect this to happen here. I can create a new stress, modify it a little bit, and say that n should be between 2 and 3. I think it will be better. Oh, the first stress test finished, and it didn't find any counterexample, and that's good. But the smaller n you choose, the bigger probability for something special to happen. Oh, yeah, we have a failed verdict. We can view it. Almost always it is because your 2 correct programs, they didn't agree. But here it says validator failed, k equals 0 violates the range of 1 to 1000. We can add this to test if we want, but we know that this is incorrect. And now you get answer to a question from the very beginning about validator. It isn't just for hacks. I wrote here some generator. It isn't long. The main is 40 lines. But because I created such a convoluted logic, I here said that, oh, maybe two numbers are forbidden, and it will be 1 and 2 for n equal to 2, and it is possible that k becomes 0. I can add here, add to tests. Oh, can't add counter test because of this. So we will not see it. Maybe I can quickly generate it here. Assert that's not a empty. I think and sure is what we need. Test lib and sure. Test lib forbids you to use some functions like assert. Then just use whatever it tells you to use. I just want to generate this exact test to show you. It helps to know bash. 416. Yep. Let's remove that. For 2 to 16, we get this test. And you have a validator to avoid a situation where you write some generator. It looks all right. Maybe when you check that white spaces are fine, n is fine because you generate from interval 1 to 1000. But for some reason k is equal to 0, and in the statement you said that it is greater than 0. And while some participants will not care about it because their solution doesn't care if k is 0, some participants will fail it, and they will waste the whole contest because you created a test that doesn't satisfy conditions from the input. Yeah. So, and we also added this sample test showing what happens if all people, every person cannot be an imposter. So let's fix the generator. I will say if a empty or this. So if a empty, then force it to just add any element. Alternatively, I could here say that if n is 2, then don't erase 2 elements. False, edit, update, saving, and I will run all stresses again. Plus in invocation, rejudge, okay? So we wait for this verdict. I think that everything will be fine, but tests are slightly different than right now, possibly. I don't think they will, but they can be. And stresses are also running. They will run each for 1 minute. I wanted to say one more thing, maybe. What was that? I think that's it. The statement is also left to be polished a little bit, but it's fine. I don't know if I said that, but if something... If something is wrong in invocation, if you hit view, at the very bottom, here you might get some warnings. And indeed, that's the case here. Variable k didn't hit maximum value, variable n didn't hit maximum value. You need to resolve those warnings. What happened is, Validator is very smart in Polygon, and it not only checks correctness of your test, it checks if you create good tests. So if Validator, if we see Validator, we have here that n is from 2 to 1000, then it makes sure that there is at least one test with n equal to 1000. And indeed, when I created tests here, I said that n is up to 100. So let's change this. Random tests up to 1000. Still, I'm leaving a lot of small random tests from between 2 and 10. They are very good to catch some small mistakes. Save script. And I only changed tests, so I will not run stress testing again. Generator and solutions are still the same. So I will see if stress tests were fine, finished, but in invocation I will rejudge to see if still programs get accepted and wrong answer as they should. Yep, everything is fine. Just to remember that if you mark some program as correct, then Polygon checks that this program should get correct. Now, if I rejudge invocation, it will be in red because something is not as expected. Oh, you see, now this verdict is in red. That's wrong. You need to resolve this issue. You see here, verdict wrong answer violates the tag accepted. Polygon sees that you mark this solution as correct, so apparently it should get accepted on every test. And right now it's wrong answer, so Polygon will check that it will get wrong answer on at least one test. And now this is not red, because this is intended. Polygon knows that you want this to get wrong answer. I think we're done. Yes, so polish the statement later. And also never mark this, because you want other testers and authors to see the changes. Also to be aware that somebody changed the statement, for example, or just be aware that somebody did something. You also have some warnings here. It's good to resolve them. But I leave that to you later. For example, there are still open issues because I put some issues there. You can close them if we already resolved that. Don't worry about checker tests. If in checker you chose the intended checker,
we use standard check.
Yeah, check. This is the one. Wait. You uploaded your own. Okay, then this is why Polygon tells you that something is wrong. Use one of those.
No, we downloaded the checkers, then uploaded them.
Oh, I see.
We didn't select it.
Then so Polygon thinks that you implemented your own checker, so it tells you to check it, to make tests. Now, what we will do is we will remove that. If I remove something by mistake, you can roll back the changes. It's fine. Polygon saves everything, like in Git. And in checker, usually we choose just the single yes or no, case insensitive, set checker. Then also think what it is for testers. When tester opens this tab, checker, when I open this and I see that you chose one of those, I know that it's correct. But when I see that you created your own file, I don't know what that is. I would need to read it carefully because maybe it's wrong. And now I bet if we commit changes again, that issue disappeared. This is stupid, but maybe also resolve that just to get rid of warnings completely. So here I would say fix tests a lot. What did I do also? Mainly that. Mainly. I will hit commit. Oh, one more thing. In Validator, as I told you, two things about Validator. One is to hit review here and compare line by line that everything is all right. I know that it's all right because I checked earlier. And also if spaces are fine, all of this. So the review button, very important. And also in Validator, it's very good to add several tests like, okay, if n is 2, then it's bad. It tells you here how to add multiple tests at once. If n is bigger than 1000, then also it's bad. If every value AI is bigger than n, it's bad. If it's smaller than 1, it's also bad, and so on. But for example, this is fine. So, create like 10 such tests if you want to make sure that your validator is fine. This means incorrect, 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 correct. Create. run tests. In queue, I need to refresh, F5. And also you can read those verdicts. For example, this one says name n equals 1001 violates the range 2 up to 1000. Yep, that's all right. This is what the statement says. Maybe what you should do is just open statement on the other here screen, not this statement, no, and compare if the verdicts are all right. And now I will finally commit the changes. The changes are validate, improved all tests, added validator tests. Mainly that. And commit. Without marking this button. This button bad. To make good generators, remember to run your generator locally for small n. What else was there? Many types of, or many variations. Like I got the idea of erasing one element, but also erasing 0 elements, 2 elements, or improving with shuffle. But almost every improvement do with some probability. I got this idea of adding sometimes a repetition, but I do it sometimes, not always. Okay, so maybe those 3 advice are important. And interval for n. It's not a must, but it's very useful to hear this say that right here, to say that n is taken from the input. It isn't always from like 1 to 1 million. In particular, if you say it's always from 1 to 1 million, you will never get a test with n smaller than 1000 or with exactly max test, because you also want to hit n equal to 1 million. So without this, it's impossible to get min test and max test if the statement set n is up to 1 million. Cool. Also, by the way, the problem is fine. Like this is a cool problem for division 4. Maybe it is too hard for the first division 4 problem, but it's fine. It's like the first division 3 problem. Like if in a real contest, as a tester, I would add here my feedback at the end. I would also here say that problem fine, maybe too hard for first slot, something like that. But we will just talk in the chat. Thank you guys for watching. I think it will be very useful in the future for any authors of problems and testers, because I believe that Codeforces, when there are like 10 testers in Codeforces, most of them don't have access in Polygon to a problem. They just get access in Codeforces interface, and they can only submit, nothing more. But if you're more experienced, you will, I guess, or if you're like a friend of the author, you will get access to problem in Polygon, and then you should do what I showed you now for this past 1 hour. I mean, not the generator. The generator, this was unusual. Author of Codeforces round will likely already know what he's doing with generator. This will be better, but you should write some solution. You should write some solution files and mark them properly. It's very important to create one good solution and multiple wrong ones. Like also here, I could add a brute force for every number, check if everything else is present and you are not present, something like that. Doesn't matter too much in such an easy problem. I could also read the intended solution to see if there is something wrong here. And because this one is so similar to my solution, it's almost the same, maybe it's good to create one more solution with arrays. Nope. Because they are almost the same as insert. Maybe not that similar. Yeah, there should be validator test. Hit the review button to compare statement with validator. That's very important. Coordinator always does that. But as a tester, you should also help. Treat this testing thing as a fight. Try to show that the problem author is stupid. It doesn't mean that he is stupid, but try to find his mistakes and be proud of that if you do that. With any review, that's the thing with any review, also code review in companies. Your goal is to find mistakes. If you do, then you succeed. So don't assume that the author is smart, so he did stuff correctly. Even if he's better than you, try to find mistakes and just be happy if you do. For example, if you get access to a contest, Codeforces round with 7 problems, there is a high chance that he messed up one of the validators. So make sure to hit review in every problem to compare statement and validator and see that, oh, there you check this up to n instead of million, or here you have 100,000 instead of 200,000. And that's your goal, to find a mistake. So maybe it will help you to just think the problem author is stupid. I don't mean insulting him. The problem author is stupid. I need to show him that he made something badly. And then you succeed if you find such a mistake. Or also you can add some tests. Like here I would add, even as a tester, I would suggest adding a sample test showing what happens if all values are present in the input. But I will also suggest, hey, there are too few tests with small n, fix that. Or let's say I come up with some strange algorithm with this strange counter test, I can add that counter test. Just maybe let author know what you did and why. If you need a single more test and it is easy to add, do it yourself. Because why author should bother? But by default, author should create tests failing all the wrong solutions. I think I'm happy about this video. I think you found that useful as well. See you in the next video. Bye bye.